Here we start. I'm beginning the recording. So welcome to session 5 of Vectors. Hope all of you are doing well. Some of you are with me in the mentoring sessions this week, and some of you are not, but as always, you can always discuss your individual doubts with me at any point of time. You don't need to wait for the mentoring session itself. So I'll quickly go over a couple of important points as some more people are joining. So I'll quickly go over a couple of the important points from last lecture's end, which are to do with the geometrical derivations we have done. So from session 4, look at a few important things, a few new important things that we've seen. So one was the triangle inequalities. So understanding all that. So if we saw the sum formula, sum of two vectors, this one. A plus B, and this angle being theta. So we saw that magnitude of A plus B being root of A square plus B square. Old and boring formula by now, but still we saw this. So from this we learned a couple of important things. So the first thing we saw is that the magnitude of A plus B cannot under any circumstances exceed the magnitude of the vector A plus the magnitude of the vector B. It cannot exceed this. Can become equal to. Similarly, it cannot become less than the difference of A and B. This was called the triangle inequality. So it becomes equal to this when theta is equal to 0, and it becomes equal to this when theta is equal to 180 degrees. And for all other values of theta, it is in between these two values. It's less than A plus B, but greater than the difference of the magnitude. So that was the first thing of the triangle inequality. But the second thing we'd also seen that the magnitude of A plus B, if you compare it with the hypotenuse that you get by forming a right angle triangle using NB. So this is the case for theta equal to 90. This is the case for theta being acute, so less than 90. And similarly, mod of A plus B can also become less than root of A square plus B square. But for that, theta has to be obtuse, so it has to be greater than 90. So these were a couple of important, sort of, you can say, corollaries or sort of inequalities that are derived from the formula of the triangle, which is this formula of course here. Now, similarly, we also saw the difference formula. So we also saw the difference of two vectors, which comes like this. If this is vector A and this is vector B, and the angle between them is this theta, then to find the vector C, let's say, which is the difference A minus B, we actually work out the sum of the vector A with the vector of minus B. So that was the explanation of how we do this operation. So pick up this vector A, place it over here, but pick up this vector B after reversing its direction. So it becomes minus B. That vector becomes like this. This is the vector minus B. So this angle was theta. That means here the angle between these two vectors, that exterior angle is actually 180 minus theta. Or rather, this interior angle is the 180. But anyway, now the thing we are interested in is the difference. So that works out to be this. And that is the difference A minus B as a vector. And this is the angle it is making. So the formula we discussed for this was, as you all know, the formula was mod of A minus B becomes the root of A square plus B square minus 2AB cos theta. So this is the same thing as the application of the triangle law, but the angle theta is replaced with pi minus theta, or 180 minus theta. So as you know, cos of 180 minus theta is minus sin theta. So that's how we have the minus sin theta. And we of course also have the other formula, which is the equivalent to the alpha formula above, which I did not write, but you're all familiar with. So this is B sin theta upon A minus B cos theta. So again, here what happens is that the sin theta remains with the positive sign, because you know that sine of 180 minus theta is plus sin theta. You know this is sin theta. But cos of 180 minus theta, that is minus cos theta. So that's why you can think of, you know, just making an adjustment in your regular triangle law, the part A, the one which is for sum, by just replacing theta with 180 minus theta, and we get these two formulas. Okay. And from here also we see that there are the inequalities. The inequality or the triangle inequality becomes like this, that again mod of A minus B, even that can go to a maximum value, which is actually the sum of the magnitudes. But this time, for that to happen, for it to be equal, they have to be anti-parallel. Theta has to be 180. So when is the difference of two vectors? If I have two vectors, for example, of magnitude 3 and 4, when is the magnitude of the difference going to become 7? When they are anti-parallel vectors. Whereas when is the magnitude of the two, magnitude of the difference of 3 and 4 going to become 1? That is the difference of the two's magnitude. It's going to happen when theta is 0 degrees. So for the sum, it is equal to A plus B when theta is 0. But for the difference, the magnitude of the difference of A minus B vector is the sum of their individual magnitude when they are anti-parallel, or when theta is 180. So that was the inequality. Then we also saw that combining the two triangles, we can get what is called the parallelogram law. Okay. And we will develop eventually lots of little ways of analyzing questions using parallelogram law. So it's a very interesting thing. So let's again practice how to construct a vector parallelogram given any two arbitrary vectors. So if my vectors are A and B, and the angle of the vector B with respect to the vector E, so these are the directions of the angle between them is this one here, theta. Then to construct the vector parallelogram, first thing we do is from a common origin, let's say over here, we draw both the vectors adjacently. They are adjacent sides of a parallelogram. You know, you're treating the two vectors like two forces, and both the forces are acting on a common particle which you have taken as the origin. So there's some when it acts, you should be able to show in the diagram that both of the vectors are acting on the same point, like two forces. So here this angle will become theta. Okay. So this is not the vector triangle anymore. This is the vector parallelogram. So that was the first step. Then the next step is you draw two supporting lines like this, one parallel to A and the other parallel to B from here. And by using these lines, now you complete the vector parallelogram. So in the vector parallelogram, we saw that the diagonal, which is from the origin to the opposite side, that is actually the sum. Whereas the diagonal, this in fact becomes the vector E plus B. Whereas the diagonal, which is here, pointing from the tip of B to the tip of P, precisely if we speak it like that. So this diagonal is nothing but the vector E minus. So you can see that in this diagram, actually, I've captured both the. So this was the angle beta that we talked about earlier, and this was the angle alpha. And you don't need to write any separate formula, because the formula for magnitude of A plus B and alpha is the same as what we got in the triangle law. The formula. Now, what you can see here is that this is basically nothing but the two triangles combined to form a vector parallelogram. Because if we individually do the triangles, they would look like this. The sum triangle would have looked like this. You would have drawn E, you would have drawn B, and then you would have calculated their sum as this one. So here, see, this is the vector E, this is the vector B, and this angle is theta. And this is the resultant equal. Now you can see that this triangle that I have drawn, this one, this triangle is present in the above parallelogram. Is this one. So this is the vector B1. This one is the same as this side. We just pushed it here. So that triangle is present within this. So that is the whole point of the parallelogram law, that you are able to see not only the sum triangle, but next we'll show the difference triangle also, and that's also present in the same triangle. So for the difference triangle, how do we construct the difference of the two vectors using triangle law? We drew the vectors A and minus B to form the sides of the triangle. So we drew the vector E, and then to that we added the vector minus B. So you can see in this diagram also, this vector is minus of this vector. In a perfect diagram, this is perfectly anti-parallel and of same magnitude. So this was the vector E, this was the vector minus B. That's why this angle becomes theta. And that's why this vector here became the difference of the two, labeled as E minus B or E plus or minus B. Now again, you can, if you compare this diagram with the one above, you can see that this triangle is present. There's nothing but this triangle. So I'll just put it on the side. That is 100% clarity. So the sum triangle is also there within the parallelogram diagram, and the difference triangle is also there within the parallelogram. You can see that here this angle is also theta. Here this angle is also. Anyway, now that's why this angle is theta. The same as this one over here. Now in this you can see that if I just do the difference, there's this one. So the difference on a triangle is very much contained over here. The same. You can see that this triangle and similarly this triangle. So that's why I told you that it is actually nothing new, but it is just a convenient way of analyzing both the things within the same diagram. And also it's easy to visualize when you're doing like things like sum of two forces. Then why would we show the forces one after the other? Because they're not acting one after the other like two displacements. They're in fact acting simultaneously at a point. So this is a more natural way of visualizing the this thing. Yeah, Snikita, I will be discussing assignment 4 problems now, in fact, because the reason I'm doing the recap of these concepts is we'll be using many of these concepts for solving the questions. And of course, for some questions, we'll also be using component algebra, which you are quite familiar by now. So that I'll be coming to the questions directly. I'm just going over what we learned last time, the parallelogram law and the inequality, because that was something new for you. And very soon, next, after we complete this, we will see the application of this in the worksheet 4 problems. Also, seeing in the messages that Nikita, you're having some problem with the audio. At my end, the audio is okay. I'm monitoring it, so it must be an internet problem at your end. But don't worry, as always, it's a recorded lecture, and we get the video lecture with the proper audio recorded. So nothing to worry about. So hope up to this point, the parallelogram law and everything is clear. So up to this point, hope you understood how the parallelogram contains both. Now, just for practice, I will also show you a parallelogram where, so by default, we had always selected vectors which were at acute angle. But what if we have two vectors which are at obtuse angle? Like one vector is like this, and one vector is like this. So how would that particular parallelogram look? It's nothing different. It's just that the angle between the two vectors, that one, this is the direction of A, this is the direction of B. So this is the angle between the two of them. How I know the angle between the two of them? If I do them from a common origin, you would easily see that A would be like this and B would be like this. So this is the angle between them, but not this one, because they're pointing like this. So anyway, so let's construct a vector parallelogram for these two. So again, step number 1, pick up that vector A and draw it from some origin. Now step number 2, draw the vector B from the same origin. Instead of drawing it at the head of A, now we are drawing the vector B also from the same origin. So it will look just the same. The only difference is there, the earlier example, the theta was active. So the parallelogram at this corner had an acute angle. Now the parallelogram at this corner has an obtuse angle. But still, ultimately, everything is the same. And our notation is also the same. Differences in the earlier example, cos theta would have been a negative, would have been a positive quantity because it was active. And in this example, when we substitute the value of cos theta becomes a negative quantity because it's obtuse. But that makes no difference at all to our treatment of the method is absolutely the same. This is our guidelines for forming the trying to draw this a little better. Oops. This is my vector B, let's say. So these are my guidelines. So it makes no difference. The angle is obtuse, but still our sum of the two vectors will still be the primary diagonal, which is from the origin or from the source of the two vectors to the opposite. How will we know the angle between the two vectors? Because that we'll have to figure out from the question. Like the question will give you some direct value of the angle or some hint about the angle over there. Or you just have two vectors which are arbitrarily drawn like this. Suppose I have a vector E like this. Another vector B is just arbitrarily drawn like this. So what you do is you pick up both the vectors and draw them from the common point like this. So draw them from the common point and this becomes the angle. This becomes the angle. So again, now you construct the parallelogram and this is your vector parallelogram. From the source to this side, this becomes the sum. So it need not always be that one of the vectors is going to be along the, along the positive x-axis, something like that. It can be in any arbitrary direction, but the treatment will be the same. Anyway, so this becomes the sum vector and this becomes the different vector. And apart from that, there is the fact that, this parallelogram looks a little different oriented compared to the first one because this angle is obtuse. Whereas in the first one, this angle was acute. But apart from that, there is no difference in our treatment of it. We will use the same formula to find the sum and difference of magnitude, and we will use the same formula to find this angle beta, which is the angle that A minus B is making with the direction of A, and this angle alpha, which the sum is making with respect to the vector. So whether theta is acute or obtuse, it makes no difference at all. Our treatment of how to construct the parallelogram, those three steps, and how to interpret which is the sum and which is the difference, that remains the same. Okay, so this is an example of a parallelogram of these type of vectors, where the angle between them is obtuse. Like this could be 120, 150, something like that. This is an example of a parallelogram where the angle between the two vectors is acute. Like this could be 30 or 53 or something like that. So that's how you understand. So now let's come to application in some of the questions. So I'm turning to worksheet 4. I will be, as usual, giving you some hints in some of the questions, and I hope that with those hints, within the next 2 days or so, you can complete the problems, and any doubts remaining, you can discuss it. Okay? Now, so in worksheet 4, one thing I want to clarify, there is a couple of typing errors. So let me first clarify that. So problem number 1, the correct answer will be 150 degrees or C. It is given at the back as A, that is wrong. Then the answer is actually theta should be 150 degrees. I'll discuss, but this is the change in the answer. And also in question 6, there is a problem with options actually. In question 6, the correct answer should in fact be that P minus Q, the vector difference, is actually 10 j cap. It is given in the back, yes, good, that's correct. It is given as the back as 20 j cap, but that is actually wrong. The mistake is actually in the diagram. In the diagram, the vectors P and Q should have been 20 instead of 10. Yeah, Harpriya, I'll just come to it out. Why don't we take vectors head to head? Why we don't is, Harpriya, you should understand from the derivation. Like when we've done the sum of two vectors, logically, why we've drawn the triangle this way, that we first draw the vector E and then draw the vector B. Because we're doing the sum of two displacements. Right? So logically, it is like this. And therefore, the resultant is like this. Similarly, when we are doing the difference of two vectors, logically, the difference is A minus B is like this. And now the parallelogram law is nothing new actually. It is just a combination of these two triangles. So whatever logic we have used for the triangle law in the first place, that same logic is the reason behind why we construct the parallelogram in that particular way. Okay. So these are the only corrections. Now I'll come to the questions. Okay, so make sure you make these two corrections. Actually, the proper correction in answer 6 in question 6 should be that the two vectors shown in the diagram, just change their magnitudes to 20 each instead of 10. In the diagram, they mark 10 and 10. Make them 20 and 20, then 20 j cap will become the correct answer. But anyway, it doesn't matter. Whatever you do. Okay, now let's come to some of the hints for some of the questions. Okay, so first I think is very easy. You have to just use the this thing, concept of you can use the formula that tan theta is equal to ay by x, but you will also understand by this that theta is in second quadrant. How you will understand it's in second quadrant? Because ax is negative and ay is positive. So when you are solving this for theta, make sure you use the correct application for the second quadrant and not for the first quadrant. Or you can also draw the vector. You can simply draw the vector and understand its angle. If you draw the vector, you see the vector is something like this because it has a negative x component and a positive y component. So then from trigonometry, you can work out how much this angle is just by finding out this angle and then like that. So that's pretty simple. Okay, then second question, just use the statement of triangle law part B. Okay, so just use that statement that we are calculating the difference of two vectors. So suppose the vectors are A and B. So mod A is given as 5, mod B is given as 5. Okay. And it's given to you that the magnitude of their difference, that is A minus B ka jo mod hai, okay, 5√3 hai. These three are given. Now you have to find the angle theta. So just use this formula that mod A minus B is equal to root of A square plus B square minus 2AB cos theta. Don't forget that it's a difference. So it will be minus, not plus. Okay? So just substitute this information over here and you will get the answer. So guys, please be patient. I know you have doubts and questions which are further ahead, but I will be discussing few of the questions. So I'll come to your questions. Okay. Now similarly in third question, again the formula. Use the formula that mod of A plus B is equal to this root of A square plus B square, this one. And use the formula mod of A minus B is similarly a formula. And then apply the condition. Apply that mod of A plus B is equal to mod of A minus B given in the question. So substitute these over here. Substitute, then square both the sides, and then from that you find cos theta. So from that you will find theta. Okay. It's a pretty easy question. You'll be able to work this out. Okay, now let's come to fourth question. Now this is the first one where there is unusual kind of application. It's not formula, it is the inequality. Okay. So A plus B plus C, the sum of these three is given to us as a null vector. This is given in the question. Okay. And magnitude of A and B are given. Yeah. Magnitude of the vector is 20. Magnitude of the vector B is 15. Now it is asking that the magnitude of C may be. It's not asking that it is. It may be which of these options. Okay, so when we are looking at maybe which of these options, we have to understand that we don't know theta in the question. So we don't know what the value is. Okay, but we do know that magnitude of A plus B cannot exceed how much? This sum. So 20 and 15 sum is 35. So kuch bhi ho jaye, whatever angle it is, it cannot be greater than 35. And similarly, kuch bhi ho jaye, it cannot be less than the difference, which is 5. So magnitude of A plus B cannot be something less than 5 or cannot be something greater. So now you see the options and you will understand. So for example, option A is saying it may be. Now why I'm saying C is this? Okay, let's understand that also. But before you come to this, you understand that C is negative of A plus B because A plus B plus C was 0. So since C is negative of the vector sum of A plus B plus C, so it implies that the magnitude of the vector C is magnitude of negative of A plus B. But since we are taking negative, that doesn't matter. So it is actually equal to the mod of A plus B. So I know that mod of C is equal to mod of A plus B. And now I have this restriction on the mod of A plus B. It cannot be less than 5, it cannot be greater than 35. Okay. So therefore you can see that C, the magnitude, has the same inequality. It cannot be less than 5, it cannot be greater than 35. So now you see option A is not possible because it's 4. Then option B is 16. So that's possible. Then option C is 40. So that's not possible. Option D is 50. So that's not possible. So that's how you attempt any of these questions. Okay. So I'm just minimizing this for some of you. Okay. Yes, I will explain the portion for the major test 1. Okay. Portion for major test 1 is up to today's lecture. That is up to parallelogram law, and today we will be studying about components in 3 dimensions. Okay. So it will be excluding the products. So cross product will also not be there, and dot product will also not be there. So it will be everything we have learned from lecture 1 to today's lecture, lecture 5, and it will mostly cover your worksheets 1 to 4. I will be giving a worksheet 5 also for today's lecture, but that will have similar questions to worksheet 4. Okay, it will just have a little bit of addition to that. By the end of the lecture, you will understand. Don't worry. Yes, Manas, you can contact me personally when you have doubts. I have always said that to everybody. You can send your doubts to me personally on message, and I will reply back and help you out with the doubts. In fact, you should do that whenever you're solving questions at home, and any kind of doubt you have, whether you've not understood the question or you understood but you're not, not sure about which formula to apply, or after applying the formula and everything, sometimes it happens that you're sure but you're not getting the correct answer. So either it's a mistake in the answer key, or you have made some mistake while solving. So in either case, you should always share your doubt with me. In fact, you should do that. It's not a question of can you do that. You should always do that. All right. So hope this is clear. Now moving on to question number. Yeah, Amok, explain the last part of. Yeah. So देखो क्या हो रहा है? वो यहाँ पे. We know that A plus B plus C is 0. Right. So now just take A plus B on that side. So that means what is the vector C? The vector C is minus of A plus B. So this is a vector equation. Left hand side has a vector, right hand side has a vector, and they are identical. So if two vectors are identical, their magnitudes have to be equal. So that means magnitude of the vector C has to be identical to the magnitude of minus of A plus B. But remember, we are taking magnitude, so sign is of no consequence. So that is the same thing as mod of A plus B. That means the vector C's magnitude is equal to the magnitude of A plus B. So that's one thing. Now what we had analyzed earlier about the magnitude of A plus B, because mod A is 20 and mod B is 15, so the maximum possible value of mod A plus B is how much? 20 plus 15 or 35. And minimum is how much? The difference of 20 and 15, so that's 5. So now whatever you are saying to A plus B, same applies to C, because mod C is nothing but mod of A plus B. So C's magnitude cannot be 40, for example. It cannot be 50, for example. Why? Because it can't be greater than 35. Similarly, it can't be A, because A said it's 4, and 4 is less than 5. Okay. Yeah, that's a different type of question. But if the magnitude of A, B, and C is given, then along with that, you have to know the angles only. So we'll use the component method. Like we've done questions like that. How to find in last worksheet also we've done. So vectors, for example, even in this worksheet, I've given you that question with the hexagon, and you have to find the sum or difference or things like that of more than 2 vectors. So we will do that by component method. Okay. Right. So now let me come to question number 5. Okay, I will just explain question 5 again. So in question 5, the magnitude of P in geometrical representation, we have to use something called polygon law. So I will come to that later. Okay. So better is that even if the vectors are given geometrically to you, you convert them to components. Okay. If you are adding more than 2 vectors, what you do is, even if the vectors are shown to you as arrows with the angles and all that, you first convert them to components and then use component algebra for finding the sum. Okay. You will always find that as the easiest method. So magnitude of the vector P is 12, magnitude of the vector Q is 16, and it is given to us that the angle between them is obtuse. So theta is obtuse. So theta is greater than 90. Okay. That means cos theta is how much? It is a negative quantity. So remember what we discussed earlier today, that mod of P plus Q, what can we say about its resultant when we know the angle is obtuse? It definitely has to be less than root of P square plus Q square. This is the condition for theta being obtuse. Now, we've written this for vectors A and B, but that same thing is applying over here. So we can see over here that mod of P plus Q will be less than the root of 12 square plus 16 square. So it will be less than 20 because theta is greater than 90. So now again you have to select which option is applicable. So you can see that. So this way you rule out option B and also option A. Now you're left with option C, which is saying can it be 10? Yes, it can be. Option D is saying can it be 2? So the answer is again it cannot be 2 because while this is okay, it has to be less than 20, but it also has to be greater than equal to what? The difference of the two. वो भी तो है ना? So the difference of the two is how much? That is 4. Okay. So the mod of P plus Q is not only greater than, not only less than 20, but also it has to be greater than equal to 4. Okay. So we have this whole condition that mod of P plus Q, not only it has an upper limit, but it also has a lower limit. Okay. So for it to be 4, what should be the angle? It should be 180 degrees should be the angle. And for it to be equal to 20, the angle should have been 90 degrees. But actually the angle is obtuse. So that means it can be up to 180 also, but it can't even be 90. It has to be less than 90. This is the condition for obtuse. That is why it can't be 20. It has to be less than 20. But it can be 4. However, it cannot be 2. Okay. So this is the slightly tricky thing we have to understand in these type of questions. Okay. So likewise, sixth question, I'm not going to discuss it, but what we do is convert the vectors P and Q, write them in I cap J cap notation. Okay. And then find P minus Q kitna hai as a vector just using component, and you get the answer. So that is how you should deal with the sixth question. Okay. Now coming to the seventh one. Okay. So it says that vectors P and Q are at an angle of 150 and their resultant sum is perpendicular to each other, to P. So P and Q are such vectors are at 150 degrees and their resultant sum are, oh just a moment, I will. Yeah, thanks for informing me. Atharva is now back in the meeting. Okay. So R is equal to P plus Q. Okay. Now given information about R is that R itself is perpendicular. Okay. So from this we have to find the ratio of the magnitudes of P is how much the ratio of the magnitudes. Okay. So now this is an interesting type of question. We can discuss this by both the methods, geometrically also as well as in terms of this thing, components. Let's first look at the solution geometrically. Geometrical solution will look like this, that if this is our vector P, okay, then our vector Q should be in general in this sort of a direction because it's at 150 degrees. So it's an obtuse angle. So this angle 150 degrees. This is our vector P. This is our vector P. But now there's some which should be from the base of P, I mean to the head of Q, that one. That is supposed to be what? That is supposed to be perfectly perpendicular to this guy, to P. This is the condition that is given to us, that R is perpendicular, where R is P plus Q. This is the condition that is given to us. Don't know why that happened. Try and see if I can salvage this. Okay. Anyway. So here I can use this triangle law logic, that if this side is P and this side is Q, okay, and this angle is 30, then I can see that in this triangle P by Q is cos 30, and that is equal to how much? That's so P is to Q, that's becoming 1:2. So that's like the simplest way of solving the problem. Okay. You can incidentally also do this problem by making the parallelogram law. Now you can say that since we've learned parallelogram, why not try this by drawing a parallelogram. So if you draw the vector parallelogram, that one will look like this. From the common base, from the common origin, we'll have to draw the vector P and the vector Q. But remember, it's given to you that the vector Q is making an angle of, oh sorry, it's √3 by 2. Is that it? My mistake. So here the correct answer will in fact become √3 by 2. So this should be √3 is 2. Alright. So this is the vector P and this is the vector Q. The same two vectors P and Q here. You can see that because I've drawn them from the common origin. So this angle should be 1. This is the angle vector. Now next step you would want to complete the vector parallelogram. So that would be this. Now that vector parallelogram should be such that the resultant sum, which is this particular vector, that resultant sum is automatically, this is the sum of P and Q. So that resultant sum should get 90 degrees. This is P plus Q. So again you can see that this is the same as this side. These two sides are Q and Q, and these two sides are P and Q. So the condition for this angle to be 90 is the same. So whether you draw the vector parallelogram or you draw the vector triangle, it's ultimately one and the same. Right, people? So this is clear by this method. I'll also show you the component method of doing this question, which is also a reasonably efficient way of doing the question. Nothing wrong with that. So again you can notice that yes, Pratinam, don't worry. If you have to log out because of internet issues, just disconnect and connect again. I will get you in from the waiting room. Okay. So this triangle is contained over here. Always check that. All right. Now next, let's move on to this one, the component method. If I go by the component method, first of all, I'll have to define some kind of axis. Suppose I define this as my x-axis and this is my y-axis. Now by default, let me just assume that my vector P. Okay, so let me just assume that my vector P by default is along the x-axis. So my vector Q will have to be like this. we have to be at 150 degrees to it, because that is what is given to us. So the vector P is like this, and the vector Q is such that this angle is 150. So now if I write vectors in component form, the P is simply its magnitude along the x-axis. But Q is basically what? Q is Q cos 150 I cap plus Q sin 150 J. Or you can see Q, now using that cos 150 is minus cos 30. So it is minus root 3 by 2 Q I cap, and sin 150 is the same thing as positive of sin 30. So that is plus Q by 2 J cap. So this is my vector Q in component form, whereas this is the vector P in component form. Now the given condition is that this sum should be perpendicular to P. So the sum should be something like this. Let's apply the condition for that now. That what should be the ratio of the magnitudes, that the resultant of P plus Q becomes like this. It becomes along the direction perpendicular to X. So you can see that the resultant, now just add these two vectors in component form. So that becomes how much? This plus this. So that is P plus of minus. So that is minus root 3 by 2 Q I cap plus 0 plus Q by 2. So that's just Q by 2 J cap. So this is the resultant. Now this resultant should be perpendicular to P. That means it should be along J cap. That means that resultant's X component should be 0. Only the Y component should be non-zero. So the resultant's X component here, you can see is how much? It is P minus root 3 by 2 Q. This term should be 0. That's the condition for this vector to become along the y-axis, along J cap. There you are. You're getting again the same thing. That P is to Q will become root 3 is to. That's it. That's all. So this is unnecessarily lengthy way of doing the question. There's nothing wrong with it, but because you're dealing with perpendicular vectors, the triangle is always easier to deal with, because you could just make use of the properties of right angle triangle and get the answer much more quickly. But yeah, the thing I'm trying to show you is it's always possible to solve any given question by using the component method. You should think of the component method as the universal method, whereas the geometrical method or triangle law or whatever, that is only it's like a trick you can use once in a while when the triangle is easy to solve. When you can understand from the question that okay, some aspect of the triangle is a well-known thing, so it will be easy to solve. Okay, so just make a note of the second solution of this also, and that was question number 7. So now we will move on to question number 8, which is very easy. So I'll give you a hint in question 8, and again 9 is also very easy. 10 is almost like a repeat of what we've done earlier. So we are very soon going to come to the more than one option type of questions, which I will guide you with next. Yeah, Jaini, I will discuss your doubts from 9th onwards also. Yes, in my 13 also I'll discuss. Componendo dividendo beta is something that you apply to scalar algebra. So you can't really apply it here for vectors. Remember, componendo dividendo that you apply is for linear algebra. No? So there you're always dealing with scalar quantities. So for vectors, you have to use the principles of vector algebra. That is why component to dividend will not be applicable in the case of question number 8. So let's look at question 8. Sorry. Question 7. Okay, I'll just give you some time. Okay. So some people are just noting this down. So we just wait another minute. All right. So don't worry, you will get the whiteboard notes also. So let's come to question number 8 next. So 8 ka dekho, what is the statement of the question given? The statement of the question given is, yeah, it is that A and B are of equal magnitude. So mod A is equal to mod B. So let's assume that that common magnitude is X. Suppose we are doing that. Now, given in the question is that mod of A plus B is to mod of A minus B is 1 is to root 3. So A plus B ka magnitude, the ratio with A minus B's magnitude is equal to 1 is to root 3. So from that we have to find the angle between the two vectors, right? Or we have to find something else. Okay, just a moment, guys. I have an animal here. What's the matter with you? Can you like to do? Yeah, so it's given that we have to find the angle between them. All right. So यहाँ पे क्या करो? Just convert this into a division. So mod of A plus B divided by mod of A minus B is equal to 1 by root 3. Or you can say that root 3 times mod of A plus B is equal to mod of A minus B. Simple. That's all we have to do. Now just apply the formula. In fact, you can even do one thing. You can square both sides before writing the formula. So 3 times mod of A plus B ka whole square is equal to mod of A minus B ka whole square. Now just apply that triangle law formula. Okay. But in that, take mod A is equal to mod B equal to X. Okay, so that's it. So by applying that formula, so you get a very simple result, and X will cancel out. You will just get this. So this will become A square plus B square plus 2AB cos theta. On that side we'll have A square plus B square minus 2AB cos theta. So from this you will get the value of cos theta. And from that you get. Okay. So this is how you should approach this type of question. Now the thing is, beta, see the angle between two vectors, na, 210 if we are getting the angle. That means we have done something wrong with our quadrant analysis, because the angle between two vectors can never be in third or fourth quadrant. Okay, so even if two vectors are looking like this, suppose one vector is like this and one vector is like this. So suppose this angle is 210. So we will not write the angle theta as 210. We will still write the angle theta as this one, which will be 360 minus 210. So that is it. 150 degrees. That's the thing. Okay. So here you will get a column. Okay. So that's eighth question. Hope that is clear to all of you. Ninth question, I'm giving you a hint what to do. So in ninth, what you do is convert A and B to I cap J cap form. So your vector A will become some unknown magnitude, but A cos 60 I cap plus A sin 60 J cap. And according to the diagram, vector B will be minus 10 I cap. Achha, Dhruv, you want to note down the previous question? Okay. I'm not saying that this is the answer you will get. Okay, that's not necessary. You have to still solve this for cos theta. You might have made some mistake while solving. See, the cancelling of your this thing, what we get from here? Cancelling of x square, we get 3 into 1 plus cos theta is equal to 1 minus cos theta. From this, we'll get 3 minus 1, that is 2 cos theta is 1 minus 3. Sorry, 3 plus 1. So 4 cos theta is equal to, so we'll get cos theta as minus half. So that will mean that theta is equal to 150 degrees. So I'm just minimizing this a little bit for step it up. Oh, sorry, my mistake. This is wrong. Okay, this means that theta is 180 minus cos inverse half. So cos inverse half is how much? 60. So my mistake. This is 180 minus 60. So it should be 120 degrees. X square is cancelling out better. Take x square common from both the sides. So take x square common here. So inside this bracket you have 1 plus 1 plus 2 cos theta. So that 2 also comes out. No? This equation becomes 3 into 2 plus 2x square plus 2x square cos theta is equal to, on the other side, 2x square minus 2x square cos theta. So that equation will become this. That much algebra you work out. No, 210 beta Pratinav is the wrong way to express the angle between two vectors. We're just expressing the angle between two vectors. Right? It is not according to any sign convention. So it has to be the smaller of the two angles. So if you got an angle as 210 between two lines, you will report it as the other angle, 360 minus 210 or 150. Okay. So I don't think this question should present any problem further. Okay. Now let's come to question number 9. In question number 9, from the diagram, you can see, this will come out to this, from the diagram. Okay. Now apply the condition that what is happening, A plus B is what is given to us, that it is along the y-axis. So E plus B should be along y-axis. So that means its x component should be 0. So when you do A plus B over here, the x component you can see is the sum of this and this. So A cos 60, which you know is half, minus 10 should be 0. It's very much like a question we've done a little while back. Okay, so this should be easy. Yes, we use the term resolve a vector or resolution of the vector as the same thing as saying express it in component form. So if I say the vector A has magnitude 10 and it makes an angle 30 degrees, resolve the vector. It means that just express the vector in component form or give the components. How much is Ax and Ay? Alright, now let's come to 10th question, which is a repeat of that earlier question we had. So here it is like the sum of three displacements is 0. So A plus B plus C, let's say the sum of the three displacements, this is 0. So again, what that means about the magnitudes of A and B and C, it means that C is minus of A plus B. That means C's magnitude is equal to magnitude of A plus B. So that means C's magnitude cannot be greater than A and B's magnitude sum, and C's magnitude cannot be less than the difference of A's magnitude and B. So now let us fit this in. So ABC in this one, the first option, they are given as 10, 12, 15. So suppose you take this as A, you take this as B, and this is C. You can see that 15 is less than this sum, which is 22. So that's correct. And 15 is greater than the difference, which is 2. So that's also correct. So yes, it can be. But for example, now let's take this one. 8, 6, 18. This is option C. I'm just randomly picking up this. So this is A, this is B, and this is C. So now C should be less than A plus B, less than equal to, and should be greater than equal to the difference of these two. Now C here is how much? 18, and the sum is 14, and the difference of A and B's magnitude is 2. So this is being satisfied, but this is not being satisfied. That means this is not possible. Okay, so this is the type of logic you have to use in these questions. The logic of the triangle inequality. Alright. Now next couple of questions, 11 and 12, I'm just going to give you a hint because they are comparatively easy. And 13th question, I'm going to help solve or at least give you the full method. So 11th question, mein kya karo? You just, it's given to you that mod A is equal to mod B is equal to 10 units each. And the angle between them is 120 degrees. And you have to just verify about what is the magnitude of A plus B, what is the magnitude of A minus B, then what is the angle that A plus B makes with respect to A. So A plus B is angle with A. So that is nothing but in our original diagram it is alpha. Similarly, A minus B, if we want to find that one's angle with respect to A, that is nothing but beta. So just apply the formula. You can apply the formula, or you can also try something interesting. You can try solving this parallelogram. See if you can use those properties. This vector parallelogram will look like this over here because A and B are at an angle of theta equal to 120 and their magnitudes are equal. So I'm giving you a nice hint that it means that the parallelogram is a special type of parallelogram, which is basically called what? It's called a rhombus. This type of parallelogram with equal sides is called a rhombus. So if you remember your geometry a little bit, you'll see there are very interesting facts about the rhombus and how the diagonals behave. So you can make use of those little facts and come up with a very nice solution of this using geometry also. So it's a bit of a challenge for you guys. Okay, that can you solve this problem without using any formula and just using the special property of this parallelogram, which is in fact a special type of parallelogram called a rhombus. Okay. So you can use formulae or geometry of rhombus. Okay. So today I'm not going to remind you about these special geometry facts about the rhombus, which you should know, by the way. But I will come back to this later and show you how you can solve it without literally writing one formula. By just, yes. So Akshat, that is correct. That is one of the important facts about, no? Just try this out by this method. It's a very nice method. In fact, this is one of the reasons why we study parallelogram law, so that we understand all these special things. You can see this is a rhombus, these sides. Okay. So nothing more I'll tell about 11th question because I want you to enjoy solving it yourself from that point. 12th is also a simple formula based. Okay, so 12th में ये use करो that mod of a plus b, if it is greater than root of a square plus b square, that means it's an obtuse angle. It's an acute angle. And if mod of a plus b, here we are talking about a minus b. So a minus b में क्या होता है? This gets reversed actually. So this, if it is greater than root of a square plus b square, it in fact means that theta is obtuse. Because the cos theta has to be negative then. You can understand that mod of a minus b is root of a square plus b square minus 2ab cos theta. So now you can see that if the left hand side, that is mod a minus b, is greater than this quantity, then that means this quantity, it has to be negative. That's that condition. So if it is negative, that means cos theta has to be negative. So theta has to be obtuse. Whereas on the other hand, if you want the condition that mod of a minus b is in fact less than root of a square plus b square, so then this left hand side has to be less than this much. So if it is less than this much, then this quantity should be positive, which means that cos theta should be positive. That means theta should be acute. So this is very similar to the inequality that we had seen for sum. Yeah, so Sandeep, I will answer your question another time, or you can just drop me a message. I will tell you about it. But like it was under 500, I can tell you that much. For more information, you can contact me personally. Yeah, it was okay, but long time back. Right, so that's 12th question. Now 13th question is going to be one of the more interesting questions this exercise. So in 13th question, it says that you have a hexagon, a regular hexagon. Of side length 20 centimeters. And now you have to analyze various things. So you have to analyze things like the vector AB plus BC plus CD plus DE. To understand about this vector. Similarly, you have to understand about the vector AB minus BC plus CD. You have to also analyze about the vector AB plus BC plus CD. So these are the various things you need to calculate in the options. So when you have something where so many multiple vector operations are there, you are advised to use components. So convert this into a component situation. So convert all the vectors in component form, like A, B, B, C and all that. So for that you have to draw a very convenient sort of diagram first. So the convenient diagram here would look like this, that suppose we do the hexagon with the base along the x-axis. That would help. We can also draw the hexagon like this. But the more convenient one will be the one which I am drawing here. You realize why? Because then something is along the x-axis. So roughly speaking, my regular hexagon will look something like this. So it's not a perfect diagram. You can do a better job on pen and paper actually. So A, B, C, D, E, F. So for example, the concerned vectors we are talking about, this is the vector A, B. And from this point to this point, this vector would become the vector BC. Like that, this vector here would become the vector C, and so on and so forth. Now what we can do is we can take some convenient x and y axis so that life is easy for us. So let's take x axis along the EB. It's going to make things very easy. Let's take y axis like this. So having done this, taking x and y axis like this, I can see that this angle will be 60 degrees. Similarly, this angle here will become 120 degrees. Similarly, this vector is along the negative x-axis because this angle is 150. So here I am just using an interesting property of the hexagon. So I'll come back to that diagram and I'm just explaining the property first. So the property of the hexagon that I'm using is this property, that if you join the hexagon's vertices with the centroid of the hexagon, that is the meeting point of all these sort of diagonals, then you get 6 equilateral triangles. Because all these sides are equal, regular hexagon का property हो जाता है. So because these sides are equal, so these angles are all equal. So you are dividing 360 among 6 equal angles, so they are 60 degrees each. And now because this side is equal to this side, so these angles also become equal. So each of these is an equilateral triangle. So now this is 60, this is 60, so like that. So that's why you will see that this angle, this exterior angle is also 60. This exterior angle is also 60. So this was already 60. So 60 plus 60, this whole thing is becoming 120. Then like that, this was 120 and this was 60. So that's why this is perfectly anti-parallel to this. So once you understand this diagram, now you can go back to your earlier diagram and understand how we write the components. So for example, the vector AB, this was a side length, how much? 20. So 20 centimeters each. So AB is just becoming 20 I cap. But what about BC? BC will become 20 cos 60 plus 20 sin 60. So that will become 10 I cap plus 10 root 3 j cap. So that will become your vector BC. Now similarly, when you work it out, you will see your vector CD will actually become minus 10 I cap plus 10 root 3 j cap. And similarly, your vector DE will just become minus 10 I cap. Okay. So now that we've got all these vectors, you can answer any of the questions related to them. So in problems involving multiple vectors and their geometry and sum and difference and all sorts of combination of calculations, you have to work it out like this. Okay. Just review with both the diagrams. So hexagon का ये property use कर रहे हैं that if we join all the vertices of the hexagon passing through the centroid, we actually get 6 equilateral triangles. Okay, if we join the vertices of a hexagon, whether we've drawn the hexagon like this or like that, we get 6 equilateral triangles. That's why each of these angles is 60. Because each of these angles is 60, ultimately that's why each of these angles also becomes 60. These angles also all become 60. So now we are keeping that in mind while we are looking at this hexagon, which is drawn such that its base AB is along my x-axis. So that means the next adjacent side will become at 60 to the x-axis. The next adjacent side will become at 60 plus 60 or 120 to the x-axis. The next one at 180 and like that. Oh, sorry, that's correct. Make this correction. Pointed out correctly, this will be minus 20 because the side length was 20. Okay, people, so this is how you do question 13. And question 14, you can do very similarly, okay, because there now you are dealing with vectors which are given in terms of angles. So just like in this question, I have related the vectors in terms of I cap and j cap. So in question 14, you make a north, south, east, west coordinate frame and write your 3 vectors P, Q and R in I cap, j cap notation. You will get the answer very easy. So I'm just leaving you with a hint for question number 14. Make your north, south, east, west like this. So also take this as your x-axis and take that as your y-axis. Then draw all your various vectors according to, so draw vectors P, Q and R as per the instructions given. Okay. And then convert them to component form. Okay. And then solve. So you'll get things very easy. Okay. And question 15, you can do it nicely by just in question 15, draw the vector E. So again, with respect to your coordinate frame, now vector E is given to you as I cap plus root 3 j cap. Okay. You will get better. Try it again. You will get better. So this vector E will look like it's something like this. you can see that tan theta is root 3, so it's making an angle of 60 degrees with the x-axis. So vector E should be a vector of magnitude 2 and this angle 60 degrees. This applies the concepts of vectors to this and you get. So now your vector B is something which is perpendicular to this, okay, and making and of magnitude 4. So your vector B has two possibilities. One is that the vector B could be like this, of magnitude 4 in this sort of direction, or it could also be like this. This is also possible, and of magnitude 4. So you have two possible, situations for vector B which satisfy the given condition of the question, that mod B is equal to 4 and B is perpendicular to E. So you can do two things. You can either construct these two vectors using the angle. This whole angle will become 90 plus 60 or 150 and the magnitude is 4. So write it in component form and check the options, or you can go reverse. You can fit the options in this and see whether it satisfies this one or this one, and accordingly which options are correct. Okay. Yeah, so just going back 14, you will get the first part, but don't worry. Try it out and you get. Yeah, so for okay, thanks. DK, I will take that into account. Don't worry about Satyam. All right, now yeah. So coming back to question number 15. Okay, 15 में देखो क्या है? Vector A is given to me. So I've drawn the vector A over here. And for B, what is given? That is magnitude is 4 and it is perpendicular to A. So that means B's direction could be like this. So if it is perpendicular, the angle with the x-axis is how much? It is 90 plus 60, 150. So one option is that B could be 4 cos 150 I cap plus 4 sin 150 J cap. But another option possible for B is that it is perpendicular but on this side now. B ऐसा भी तो हो सकता है, be like this. It can also be perpendicular to A and like this. So then it would be at an angle of minus 30 degrees, or what if you could write properly as this, 330 degrees. So for the second case, B would be equal to 4 cos theta I cap plus 4 sin theta j cap, where you would substitute theta as either plus 330 degrees or minus 30 degrees. This is one in the same thing, but it is basically in fourth quadrant. In fourth quadrant, what happens? Cos is positive and sine is negative. So just use the formula for quadrant 4 and solve it and you'll get the answer. Alright people, so that is about the worksheet discussion. So I'm just minimizing this for a moment, complete this, and then we will come to the next part of today's lecture, which is further discussion about component algebra, where we will start with the three-dimensional discussion today. Okay, so I'm just coming, just note this down. Maybe you have to come out with pretty. Okay, I will admit you, don't worry. Okay, so people, this was a very important part of today's lecture because worksheet 4 is going to be the most important part of your preparation for the test coming up on 17th. Okay? We have a little bit of discussion remaining today for three-dimensional vectors, which we will complete, and that will also be tested in your test on 17th. But that the application part will be very easy. Initially, when I'm explaining, there might be some tricky things, but the application part will be very easy. Whereas worksheet 4 में application थोड़ा tough था. So worksheet 4 is the most crucial aspect of your preparation for your test coming up. So make sure, first of all, you clear all your doubts up to worksheet 3 with me. If any question is pending or any question the answer is not matching, or even if you've done the question and you're not 100% sure that your method was okay, or you want to discuss something else की दूसरे method से करना था तो क्या करना था or something like that, please contact me directly. In fact, when you're discussing questions that you've already done, it always helps me if you can, if you can just give me a clip, send me a picture of the working that you've done in your notebook already, and then I can take a look at that and guide you further that where you could add something to that or where something might be wrong by mistake or whatever. So that thing you can do. So first do that, complete anything pending in worksheet 3, please try to complete by tomorrow or day after, and then hit the problems of worksheet 4. Some of the problems you might have done already, some are pending, which you will be now able to do with the discussion that we've done today. So complete everything and try by end of this week at least, latest by Saturday or so, you try to discuss and complete worksheet 4. That way you will be in a very good position for the test coming up next week. You will have one complete week time for revision. So you can do a lot of additional questions. I will send you a list of questions that you can do from your module also, the vectors module, the mathematical tools for physics, that PDF module that has come. So some questions additionally from that you can do. There are some solved examples, so you can go through that also. So plus my worksheet 5 will have a lot of revision questions also, because what we are learning today is very easy. So that and all you can do very confidently, and by the time the test comes, you will be well prepared for. Yes, dot product beta we'll be discussing in the next lecture, but that will not, products will not be part of the test. Okay? Both scalar and vector product, the cross and dot product will not be part of this test. It will come in the next test. So don't worry about that. Okay? So now let us come to the final part of today's lecture, which is the additional learning part. Okay? So we will see something very interesting. We will see components in 3 dimensions, which is the ultimate thing, because the maximum number of components a vector can have is 3. If you study relativity, it's a different matter. There it's very interesting. Time becomes like a 4th dimension of space. So apart from x, y, z coordinates, you also have the time dimension. But I will not get into that today. And in fact, that is not part of your syllabus here also. But anyway. So for this, the first thing we have to understand is what we call a rectangular or Cartesian three-dimensional coordinate frame. How that looks like, and how to first understand the axis and how they are drawn, etc. Then we can discuss about. So this is the first aspect of 3D vectors, that a rectangular three-dimensional coordinate system. Okay. So I'm attempting to draw the diagram like a three-dimensional diagram, and I'll explain how it works. So before I explain the whole thing, don't get too worried about what I'm doing. Now imagine in this diagram, now listen to me very carefully. Imagine in this diagram, ये जो point है, origin, this is the corner of your room. Right? You are sitting in a room which is roughly rectangular. So the wall that you are facing, उसका जो bottom right corner है, whichever wall you are facing, the bottom right corner of that wall is this origin point. Okay. Now the edge of the floor that you see from that point, this is your x-axis. The edge which is common to the two walls, this is your y-axis. So they are perpendicular to each other. Now the front wall, that also has an edge with the floor. The side wall also has an edge with the floor. So this one is nothing but the z axis. Okay. So the three axes are the three perpendicular edges that are formed by, this edge is formed by wall and wall, this edge is formed by floor and one of the walls, and this edge is formed by the floor and another wall. So they are perpendicular to each other. So even this angle is 90 and even this angle is 90. In fact, your floor is basically this plane, the exact plane. If you imagine that the origin which I have drawn is a point which is the corner of your three things, the two walls and the floor, where they are meeting, that corner point is O. So this is nothing but your floor, okay, which we are taking as the exact plane of your room. Okay. Whereas one of the walls of your room is this one, which is formed by a particular wall, the one which is to your right hand side, and the floor. So this is a vertical wall. Okay. So this is my XY plane. And the other wall, which is directly in front of your eyes, that one is this. And your y-axis is nothing but the edge that is formed by the two walls, the one which is right in front of your head and the one which is towards your right hand side. So this is your other wall. This is also a vertical wall, and this is your YZ plane. So this is the easiest way to visualize three dimensions by drawing in on a piece of paper. Because ultimately you are restricted. Your piece of paper is not three-dimensional; it's two-dimensional. So it's left to your imagination to understand what are these axes which are mutually perpendicular. So imagine the floor is this exact plane, and this corner point is the point in your room where the front wall's edge, the side wall's edge, and the floor's edge, they all meet at that common point. That is your common point. So that is what we mean by the axis, the x, y, and z axes are mutually perpendicular. Therefore, the planes xy plane, yz plane, and the xz plane, they are also perpendicular to each other. So what we mean by this statement that these are mutually perpendicular, what we mean by the fact that they are mutually perpendicular means that x is perpendicular to y, x is also perpendicular to z, and y is also perpendicular to z. So any pair of axes are perpendicular to each other. That is what we mean by this. Now I'll give you another way of visualizing this. Okay, this is just the first method. But first of all, you make sure that you're trying to understand this in context of the three-dimensional room in which you're sitting. That's the best way to visualize how the axes are mutually perpendicular. Now another way to visualize this is, think of it like this. Another way to visualize is, imagine you have a rectangular box like this. Wait, I'll just draw this better. So imagine we have a perfectly rectangular box, which for whatever reason I'm struggling to draw a little bit, but doesn't matter. Now, in this box, imagine that this corner is my origin. So, this is my x-axis. This is my positive x-axis. This is my positive y-axis. So, this becomes my positive z-axis. And of course, on the other side, this is continued. So, this is the negative z-axis, z prime. And this is the negative x-axis. That's x prime. And this is the negative y-axis. So those planes that we were talking about, they are now this. This is your xz plane, which is the floor of the box. This is your xy plane, which is one of the side walls of the box. And this one, let us see. This is your yz plane, which is another wall. So you can see that these two edges are perpendicular to each other. These two edges are perpendicular. On the floor also these two edges are perpendicular. So these are the different ways in which you can visualize your three-dimensional coordinate system, even though you are restricted to draw it only on a piece of pen and paper. I mean on a piece of paper. Yeah, I'm coming to the above slide also. So this is one way to visualize this. You can see that here I'm looking at it at a slightly different angle. The way I'm seeing the rectangular box below, I'm seeing it from a slightly different angle. So I could even draw this rectangular box like this. I'll draw another diagram in between and you'll understand even better. So I could also represent this in this manner. Just draw one in between. So now in this box, if I label this point as my origin, and now this side is becoming my x-axis. This edge is becoming my y-axis. This edge is becoming my. So these are my mutually perpendicular x, y, z axis. So you can see. So this is one plane. This is one plane. This is one plane, and they are mutually perpendicular. Now you can see that these diagrams make sense with respect to each other. So what you can do is conceptually you can understand what we've done here is that this is a rectangular cuboid and three mutually perpendicular edges with common vertex O. Those edges are becoming our x, y, and z axis. So this is how we visualize our x, y, z coordinate field. This is the first step. Okay? Understand what is a mutually perpendicular axis or what is a Cartesian coordinate system that we draw in 3 dimensions. It has to have 3 axes which are mutually perpendicular. Okay, people, so hope you are able to visualize this in context of the diagram versus how you see the room in which you are sitting. Just take 2 of the edges which are common with the floor with the walls as your x and z axis, and take the common edge of the 2 walls at the corner, the vertical one, as your y axis. So accordingly, you have your x, y, z axis. Alright, so this is okay. So that's okay. Now we come to a very serious question, that how do I decide my direction of z axis? So the relationship between x, y, and z axis directions. Now you might say that okay, I have already decided that mutually perpendicular है. So that's already decided. इसमें कौन सी बड़ी बात है? But there is something in that. I'll explain what there is. And that is like this: that if I have taken my x and y axis like this, suppose I have decided that okay, this is my x axis, this is my y axis. Again, now this is that 3-dimensional kind of drawing, so they are actually perpendicular to each other. It looks like an obtuse angle, but you have to imagine they are in this plane. Okay. So now see, there is one direction like this. There is also one direction like this. Now this direction is also mutually perpendicular. This direction is also mutually perpendicular. But we have to define one of them as my positive z-axis. Otherwise, there will be a problem. Otherwise, when I write the coordinates as some x, y, z, and somebody else writes the coordinates according to the other z-axis, then my method will not match with that person's method. So I have to develop some convention for the direction. So in fact, as it turns out, this is not the z-axis. This is in fact the z-prime axis. This is the negative z-axis. This is the correct direction of the positive z-axis. Okay. But the question is, how do I judge that? How do I decide that? So for that, for the relationship of x, y, z perfectly, I think many of you already know what it is. We follow what is called the right-handed system. Okay. Or you can say right-handed convention. So for deciding the direction of the z-axis with respect to your xy axis or with respect to your xy plane, we use what is called the right-handed system. Now the right-handed system is very simple. Okay. That if you draw your x-axis like this, now I'm coming back to 2-dimensional diagram, and if you draw your y-axis like this, such that in the plane of the paper, now this is your positive x-axis, and this is x prime. So this is the positive direction. That's the negative direction, and this is your positive y-axis. This is y prime. Okay. Now here to decide your z-axis, you'll realize that you have 2 options. Now listen to me very carefully. Here you have 2 options for z-axis. One option is that z-axis could be coming out straight towards you. It could be an arrow that is pointing straight at you, coming straight out of the paper. Or suppose you've drawn this diagram on the floor, so z-axis is coming straight vertically upwards towards you. Another option could be that it's going into the plane of paper. On the other hand, it could also mean that the z-axis is in fact going into the plane of the paper. So how do we decide which one is the correct option? For that, we use what is called the right hand palm rule. Now the right hand palm rule is like this, that, or what we call simply the right hand rule. You use your right hand palm such that you stretch your thumb along the positive x-axis. Take your right hand and stretch your thumb along the positive x-axis. Okay. Then stretch the four fingers along positive y-axis. So roughly speaking, and excuse my drawing skills here, which are next to absent. This is how your palm will look. Roughly speaking. Very bad condition. This will look something like this. Your four fingers will look like this, and your thumb pointed out will look like this. So this is your thumb. It's stretched out along the positive x-axis. Whereas your four fingers, they are stretched out towards the positive y direction. This is the x-axis. Then, whichever direction your palm is facing. Okay. So in this case, if you use your right hand, so I'm going to switch off this and show you here. So you stretch your thumb, okay, along your x-axis, point your fingers along your y-axis. Okay. So now you can see me in the camera. I am facing you. और मेरा x-axis का positive x-axis का direction क्या है, ये वाला. This is the direction of my positive x-axis where my pen is pointing. And what is the direction of my positive y-axis? It is this direction in which the pen is now pointing. So now you can see I've placed it such that where is my palm pointing? It's pointing straight towards you. So that means what will be my direction of my z-axis? It will be where my palm is pointing. It will be like this. It will not be like this. It will not be pointing backwards. It will be pointing like this. It will be pointing in which direction? In the direction in which your palm is facing. Okay? So if your thumb, I'm repeating, if your thumb is pointed along your x-axis, so my x-axis is in this case like this. Your fingers are positioned along your y-axis, so my y-axis is like this. So this is my y-axis, this is my x-axis. Then whichever direction your palm is now pointing, facing, that becomes your direction of your positive z-axis. This is what we call the right-handed system. Okay. And this is what you have to, yeah, it's similar to Fleming's left-hand rule. You can use Fleming's left-hand rule alternately also, but personally I find Fleming's left-hand rule more confusing. So I prefer the right-hand palm rule. Okay. So now what happens, once you've done this, next, your palm faces, okay, your palm faces the direction of the positive z-axis. But remember to do this with your right hand. Okay. Very important, especially for lefties. If you do the same exercise with your left hand, ulta ho jayega. Okay. I'll just repeat it for you and show you. So see, I'm doing this with my right hand. Now X is pointing like this, Y is pointing like this. So where is Z pointing? Straight towards you. It's coming straight into the camera like this. But if I were to do the same thing using my left hand, so I point my thumb towards the x-axis, I point my fingers along the y-axis. Now where my palm is pointing, it's pointing away. So ulta ho gaya. It's not pointing along the proper z-axis. It's actually pointing along the negative z-axis. So remember, when you're using the right hand palm rule, make sure you use your right hand and not your left hand, because otherwise you will get just the opposite direction. Okay. So this is actually similar to Fleming's left hand rule. Okay, don't worry. I will speak to you better. Devkaran, just drop me a message after the lecture on WhatsApp. I will speak to you. Okay? During the lecture, I will not be able to unmute people and speak in them. So it causes a problem in Zoom actually. The whole software hangs up. So. Whatever difficulty you're having, I will discuss with you after the lecture. Don't worry. So this is the right hand palm rule or the right hand thumb rule. That point your right hand thumb along the x-axis, stretch your fingers along the y-axis, then wherever your palm is pointing, that becomes your positive z-axis. Okay, have you understood this? So that's how we decide between the positive and the negative z-axis. So, again, coming back to that three-dimensional diagram, if this was your x-axis and this was your y-axis, like this. Now, what you'd have to do is, you'd have to place your thumb pointing in this direction and your four fingers pointing like this. Now, when you do that, you'll automatically see, when you do that with your hand, you'll automatically see that your palm is actually facing in this direction. This is where your palm faces. Your knuckles of your fingers are on the other side. So your palm is actually facing in this direction. So that's why your positive z-axis will become this one. This will become your positive z-axis. So not z prime, z. And the other side will be the negative z-axis. So this is just about the right-handed convention. Okay. So it's just a matter of convention. We could have used a left-handed convention also, but then we would have drawn what is called a left-handed coordinate frame. This is what is called a right-handed coordinate frame. And just for the sake of uniformity in our mathematical laws, in physics and in engineering, actually in science and engineering, we always draw Cartesian coordinate frames according to the right hand. Yes, this is very similar to Fleming's left hand rule. If you are familiar with Fleming's left hand rule, you can use that and you'll get the same. So Fleming's left hand rule is like this. I will just again show you. So Fleming's left hand rule में हम क्या करते हैं, that we take our left hand and make this sort of diagram. So I hope you are able to see to a certain extent. So in that, what is happening is that if this is my x-axis, this one, and this is my y-axis, this one, then my thumb points along the z-axis. So x, y, and z are respectively given by your middle finger, your forefinger, and your thumb. But why I find Fleming's left-hand rule difficult is, you have to remember the middle wala x hai, fourth finger is your y-axis, and your thumb is your z-axis. If you confuse those things, it becomes completely wrong. Whereas your right-hand palm rule is very simple to remember. X along the thumb, fingers along y, and so wherever your palm is pushing, wherever your palm is pointing at, that becomes your right hand. Okay. Yeah, so if you're not understanding this immediately, don't worry. Just go through my notes after the lecture. Okay. And in the notes, pay attention to this what I've written over here. I've written the rule for you. So you just stretch it out a few times. You'll understand. Just follow the instructions of what I've written here. That stretch your thumb along the x-axis, your fingers along the y-axis, and see where your palm is pointing. Wherever it is pointing, that is becoming your z-axis. Just practice this a couple of times and it will become clear. Now, next let us move on to writing a vector in three-dimensional component form. Yeah, Dhruv, let it be. नहीं समझ में आ रहा है तो फिर रहने दो, बाद में समझ जाओ. Just concentrate on the next part I'm explaining. Some students have difficulty with three-dimensional initially. It's a matter of how you visualize. If you're not able to visualize, you're not able to visualize. You cannot help it. Okay. With time, you will understand. As you're solving more questions, with time, you will understand. You just then concentrate on the formula. Forget about visualization for the moment. So when we talk about vectors in 3D, Now the first thing is based on the XYZ coordinate frame. We define unit vectors, the base unit vectors, the standard unit vectors. So your I cap and J cap is the same as what it was before. But now you have the third unit vector, which is called K cap. And this is the unit vector along positive Z axis. This was the unit vector along positive X axis. And similarly, this is the unit vector along positive Y axis. Okay. So in this diagram, this will be your I cap along the X axis. This will be your J cap along the Y axis. And along the Z axis, this one will be your K cap. And they are mutually perpendicular. So again, according to right hand thumb rule, stretch your thumb, that should be along your I caps. And then next stretch your fingers, that should be along your J cap. And then wherever your palm is pushing at, wherever your palm is pointing, that direction in which your palm is facing, that becomes the direction of K cap, or that becomes the direction of your positive Z axis. Those of you understanding who are able to visualize, very good. Those who are having problems visualizing, just let it be, it doesn't matter. Just follow the instructions which I am leaving in the notes, you will be able to solve the questions. It will happen to a small percentage of students. You will really struggle to visualize 3 dimensions initially, but with practice it will happen. Just don't give up. So once you've done this, you've written your components in 3 dimensions. I mean, you've written a unit vectors in 3 dimensions, I cap, J cap, and K cap. Now, any vector, yeah, any vector will be expressed now as an X component into I cap plus a Y component into J cap plus a Z component into K cap. So this is the general formula of any vector in 3-dimensional component form. Okay, so this is 3D component form. So just with the 2-dimensional system that we had originally, now we just add one more component, which is along the Z axis. So AX, AY, and AZ are respectively the X component of vector A, the Y component of vector A, and the Z component of vector A. Okay, so these are the no problem. Alright, so these are what we mean by the 3 components. Now we learn to visualize this also, we'll understand. Now, as usual, you know that these quantities AX, AY, and AZ are scalars. They are just numbers. It's the thing with the direction is I cap, J cap, and K cap. So AX is just a number. It's multiplied with the unit vector, so it becomes a vector. AY is multiplied with the unit vector J cap, so it becomes a vector along the Y axis. And AZ is multiplied with K cap, so it becomes a vector along the Z axis. And the sum of those 3 vectors is nothing but the vector E. So AX, AY, and AZ are just scalars, which just like previously we've seen, they could be positive or negative quantities. Okay. So scalars that can be positive or negative, either for example, we could have a vector which is, let's say, 2i cap plus 3j cap plus 5k cap. Or we could have another vector where some of the components are negative. It's minus 3i cap plus 2j cap, let's say. And again, minus 4k cap. It's okay, there's no problem. But understand that here Bx is minus 3. So B's x component is minus 3. It's a negative component. Similarly, By is a positive quantity. It's plus 2. But similarly, Bz over here is minus 2. Whereas for A, you can see all three components are positive. Ax is also plus 2. So that's depending on the direction in which the vector is lying, whether the component should be negative or positive. Can be, no? We've discussed this before. Scalar quantity can be negative. Like for example, when we write coordinates, they are scalar quantity only. When we write the coordinate of a particle is x equal to minus 2, it's a scalar only, it's not a vector. When we write it as the position vector or the displacement is minus 2i cap, then it becomes a vector. So this is a scalar. This is a vector. If I say that the change in velocity or change in speed is minus 2 meters per second, that means the speed has decreased by 2 meters per second. So this is which kind of quantity? It's a scalar quantity. So scalars can be negative. You might be confusing with kinematics. Now in kinematics, if we have one-dimensional motion, we show the direction by sign. Okay, so often from that you might think that okay, algebraic sign means it has direction, but it's not necessary. That is only in 1D kinematics. Okay, so these are examples. Okay, now let us understand. Let's interpret. Let's understand the geometry of a vector in 3D system, in 3D components. Let's come back to this vector which I have labeled as EXI cap plus EYJ cap plus EZT cap. In fact, let me just take an example. Suppose this is 12I cap plus 3J cap plus 4K cap. Suppose an example. So now let's visualize this, what this looks like. So for the visualization, let me draw my three-dimensional coordinates first. So generally, so that our diagrams are not too cluttered, we don't show the negative axis. But you have to understand they are there. Okay? This line is not just from the origin to the positive side. The negative axis is there on that side. The negative axis is there. So now see, I am drawing this vector. That the vector is AXI cap plus AYJ cap. This one. So where will the vector AXI cap lie in this? It will lie like this. Think of it like a displacement. Okay? So AXI cap will be like this. This will be the vector EXI cap. It will be the line joining the origin with this point, whose coordinates will now become 12, 0, 0, because this EX I had taken was 12. Now similarly, where will the vector AYJ cap lie? It will lie like this. This will be my AYJ cap, where this point will be on the y-axis having a coordinate 0, 3, 0, because I had defined AY as 3 in the example. Okay. And similarly, where will my third component be? My third component expressed as a vector will be like this. It will be along the z-axis. It will have a magnitude of 4 along the positive z-axis. So it will be the line joining the origin with this point, which is 0, 0, 4. And this will be the vector EZ K cap, where EZ is equal to 4. Okay. So I haven't come to the vector A yet in the diagram. Okay. All I'm showing you is that the individual components of the vector E, how they are looking in the XY plane, XYZ plane, I mean in the XYZ space. I'm just showing you that what these individual vectors look like. The vector AX I cap, AY J cap, they look like this now. Now from this, we will construct the vector E itself, how it looks in this diagram. We will construct that also. But first we just understand this. Okay? We'll just take another 2 to 5 minutes. Yeah, people, I'm getting requests for unmuting, but I've said again and again that it is not possible to unmute during the Zoom lecture. So please, if you have anything to talk to me, individually discuss, then wait for the lecture to end, and after that you can contact me. I'm available on the WhatsApp number. The same number that I'm there on the group, you can discuss on that. But I'm in the middle of a lecture. I cannot speak to individual people right now. Everybody else will have to wait for me to finish talking with you. Please have some patience. Let the lecture finish. After that, you speak to me. Yeah, after the lecture, you can speak to me. I've told you many times. Many times I've said. Alright, so hope all of you understood these vectors, how they're looking. AX I cap is along this edge. AY J cap is along this edge. And so now let us look at how the vector A will look. Now for that, what I suggest again is that we will draw that rectangle so that we understand it best. Okay. So imagine we have this rectangular box, this rectangular cuboid, to be precise. Now this one itself now has, let's say, it has these dimensions. This side is 12, this side is 3, and this side is 4. Okay. And now what we've done is we have selected this point as our origin. So we took this as our x-axis. This whole side as our x-axis. We took this side as our y-axis. And we took this side as a z-axis. Let's say that this corner point is the point E. So it's having coordinates what? 12, 0, 0. This is lying on the x-axis and this side is 12. Similarly, this corner point let's say B, and it is having coordinates 0, 3, 0. And this corner point is C, and it's having coordinates 0, 0, 4. So this side is 4 and this side is 3. Okay. So from the earlier diagram, if you compare, the vector OA here is actually 12 I cap. The vector OB is 3 J cap. And the vector OC is 4 K cap, which further we had written as EX I cap, EY J cap. This is EZ K cap. Now from this we want to construct the vector E. This is the sum of all these. Okay, so now just think of A like a displacement. Okay, so this is where it will becomes interesting. You started from the origin. So what is your first displacement? Is this one? You went from O to E. So this vector here is your EXI cap, which is 12 I cap. Okay. Now from the point A, you made a displacement of how much? 12. You made a displacement of 3 J cap. So 3 J cap is this one. Just follow my cursor. 3 J cap is this one. But instead of making the displacement from O, where you made the displacement from? You made it from here. So you reach this point. So this is your second thing, which is EY J cap. So now after completing a displacement of EXI cap plus EY J cap, what has happened? You have started from the origin, reached this point A, and now you reach some point over here, let's say D. अब इस पॉइंट के कोऑर्डिनेट्स कितने हो जाएंगे? इस पॉइंट के कोऑर्डिनेट्स हो जाएंगे 12,3, right? And then to that you have added the displacement AZ K cap. That is how much? That is 4 K cap. So that is this one over here. Okay? That is precisely this displacement C, which we had seen earlier. But you are not making it from O. You are making it from this point B. So your third displacement is C. So your three vectors EXI cap, EY J cap, and EZ K cap, they are actually the edges one after the other. They are the three mutually perpendicular edges of this cuboid. This edge 12 I cap, then this edge. So again, follow my cursor. So this edge 12 I cap, then this edge 3 J cap, plus this edge which is 4 K cap. And after completing this, you have reached this point E, let's say. Okay. So what are the coordinates of that point E now? The coordinates will become 12, 3, 4. There's the coordinates of the point D, but 12, 3, 0. And the first point we have come to was E, which was 12, 0. Okay. So when you completed AXI cap from the origin, you reached the point E, which is on the x-axis 12, 0. Then you made a displacement of 3 J cap. So you reach this point B, which is lying in the XY plane at coordinates 12, 3. Z coordinate is still 0. Then you came out on the Z axis along this line DE. Okay. So you made a displacement of 4 along the Z axis. So your Z coordinate changed from 0 to 4. So now what is the vector E? It is the sum of these. So in the diagram, what is the vector E? It is this one. So it is basically what we call the body diagonal of the cuboid. So that is the geometrical interpretation of vector in 3 dimensions. So this vector, which is basically from one corner of the cuboid to the other corner of the cuboid, going through the body, it is called body diagonal. So that is becoming my vector E. So now you can see the vector E, the interpretation becomes like this, that the vector E is actually the vector joining the origin with the opposite side's corner, which in geometry language is called the body diagonal. Is the body diagonal of a cuboid with sides. So those sides were OA, which was 12 I cap, then ED, which was 3 J cap, and then finally D to E, which was 4 K cap. Okay, these are the mutually perpendicular sides, or you can call them edges also. So that is how you understand geometrically how you have converted a vector in 3-dimensional component form into understanding what it represents geometrically. It represents the body diagonal of such a cuboid, जिसके edges क्या है? X, Y, and Z, or 12 I cap, 3 J cap, and 4 K cap in this case. Okay, so this is the geometrical interpretation of vector in 3 dimensions. This is the geometrical. Okay. Now the final thing here we can see from this is, therefore, if this is the body diagonal, what will be the magnitude? It will be according to the geometrical formula, square root of sum of squares of the sides. So that is ax square plus ay square plus az square. This is just directly coming from the geometrical formula that if you have a cuboid of sides, okay, LB, and this side is B, then the length of the body diagonal is this one now. This body diagonal's length becomes square root of L square plus B square plus B square. तो यहाँ पे length, width and height actually कितना है? They are ax, ay and az. So that is why the magnitude of the vector E just becomes square root of ax square plus ay square plus az square. And that's not too hard to understand at all, because in 2D it was just this. Now to that you are just adding a third vector, which is perpendicular. Yeah, Pratinav, you can leave the meeting. It's no problem. If you are getting late, you can leave the meeting, because I have a certain target to teach. And sometimes it gets late because I'm answering your questions. So I can rudely break your questions in between and not answer. Or, I can end the lecture at 6 without teaching the whole thing. If you're getting bored and you're tired or you have something else to do, you can leave the lecture. I have no problem. Your attendance is marked. You will get the video later. But, I will not take instruction from some student that, you have to end the lecture at this time and this and that. Yeah, it doesn't mean I take the lecture for 3 hours extra, but few minutes here and there. In fact, the more you disturb me with such side queries, like, sir, can I message you? Sir, can I talk to you? This, that, during the lecture, the more the lecture gets delayed. I have no problem. Yeah, better, Diana, to answer your question, a three-dimensional figure like a cuboid, it has different types of diagonals. It has face diagonals, okay, and it has body diagonals. There are different types of diagonals. So that is why we are specifying that we are talking about body diagonal. For example, for a cuboid like this, okay, any cuboid like this, this one is a face diagonal. This is a face diagonal. Okay, similarly, this one is also a face diagonal. Okay. But if I draw a diagonal through the body of it, passing through the centroid, from this corner to this opposite corner, like this one is what we define as the body diagonal. Okay. So that is why it is very important to understand that in the case of a vector, it is not the face diagonal. It is the body diagonal of a cuboid, which has sides ax, ay, and az. Okay. So just saying diagonal would not be sufficient over here. We have to specify that it is the body diagonal. Right. So this is the important formula related to 3 dimensions. That when we express the vector in 3-dimensional coordinate form, the magnitude of the vector becomes this. So for example, if I have a vector which is, let's say, this one only, 12 I cap plus 3j cap plus 4k cap. So mod of A kitna ho jayega yahan pe? Magnitude of A will become 13, because you know that this is 144 plus 9 plus 25. That works out to be square root of 169, which is working out 13 units. So the magnitude of the vector becomes like this. Okay. So just as another example now, suppose we have the vector E is 2I cap plus j cap plus k cap, and I have a vector B that is I cap plus j cap, and I have the vector C which is defined as A plus B. Okay. Now I ask you, find the vector C and find its magnitude. Okay. So Nothing extra in this. This is just like your two-dimensional approach, but with the added component. Okay? So the vector C, so how we'll do this is the vector C is equal to the vector A plus the vector B. So this is AX plus BX I cap plus similarly AY plus BY J cap plus similarly AZ plus BZ. So what we have done for Y and X, we have to now add for Z. So यहाँ पे substitute कर लो. So AX is how much in the above diagram or in the above example. You can see our AX is 2 and our BX is how much? 1. So this is becoming 2 plus 1 I cap. Okay. Then AY you can see is 1 and BY is also 1. So this is 1 plus 1 J cap. And then as far as Z component is concerned, A has a Z component of 1, but B does not have any Z component. So its Z component is 0. That's always possible, right? Some component can be positive or negative or even 0. So now what is our vector C becoming? It is becoming 3 I cap plus 2 J cap plus 1, or that is directly J cap. So this is my vector C. And therefore its magnitude now, the magnitude of the vector C will become root of x square plus y square plus z square. So that is root of 9 plus 4 plus 1. So that is square root 15. And we can leave the answer this way. We don't have to calculate in points. Very close to 4. But remember, it is root of x square plus y square plus z square, not oh sorry, root of 14, my mistake. Yes, you are correct in that. Thanks, Andrea. The answer is not root 15. The answer is in fact root of 14. So this is about vectors in 3 dimensions. So the important thing in today's lecture was actually, I mean, apart from the worksheet 4 and all those methods we discussed, about 3 dimensions, the important thing was that you have to understand the right hand palm rule and how the relationship between x, y and z axis works. Apart from that, its application in vectors is very simple. Just like you have 2 dimensions, you add a third dimension az k cap. So just like in 2D, the magnitude of the vector is root of x square plus y square. Similarly, in this, the magnitude becomes root of x square plus y square plus z square. Rest, there is no difference at all. It is just like we did addition, subtraction, etc. in 2D. Same methods we apply here also. It's just that in addition, there's the z component. So it will be like, yes, I'll move the screen upwards. I'll be sending you the notes also. So don't worry. So this. All right, people. So that is it for today's lecture. You will get the whiteboard notes and the video very soon. So don't worry about that. Okay. And please complete worksheet 4 with the hints that I've given you. And try to complete any problems that are still remaining for you by the end of this week positively. Better if you can do in the next 2 or 3 days. Okay. And send me any doubts that you have. With that, you will be well prepared for the test coming up. Okay. Next week also, I'll do some revision questions and all to help you for the test. But if you do your worksheet 4 properly with all doubts solved through me, you are more or less prepared for your test. Then you have to just keep doing revision of your notes. Okay. That's it, guys. Thanks.